Swayam Prabha. Digital India. Educated India.
Hello everyone and welcome to a new discussion which we are going to have on DM sources from where you can get DMs of different resolutions generated using different techniques, and also we will discuss limitations and future of digital elevation models. So basically we are coming to the end of utilization or applications of digital elevation models, and of course very near to the end of this course. But before that I should close with this one, that this with the digital elevation model, and that without which it is very difficult to work for GIS or in GIS. So it is one of the essential source of information. You have seen in various discussions in previous 10-15 lectures that how a digital elevation model can be exploited for different types of applications in many civil engineering projects, in earth sciences, in environmental studies, in hydrology, and also for these non-conventional energy sources or renewable energy sources like in sun, solar or wind also. And I am sure that as new and reliable digital elevation models becomes available, people will exploit more, they will develop more bridges between different applications and of course GIS. So what we can say in nutshell, that the digital elevation model is indispensable, without which not much progress can be done. So remote sensing data and digital elevation model, these are now very important components or input components of GIS. So basically what we do, as we have seen, that topographic feature extractions, lot of features starting from slope aspect even to runoff analysis can be done through surface hydrologic modeling, and then one can exploit for slope stability analysis like in landslide hazard zonation and other things, or also in soil erosion study. So one source of information, that is digital elevation model, n number of applications, virtually n number of applications which we are talking now. So for a very accurate surface elevation information, which is because if analysis is done on a digital elevation model which is not accurate and not reliable, then any kind of results which are coming, one will not have a high level of confidence. So this is very critical component, and that for scientific research and for commercial or military applications, this has to be very accurate, digital elevation model as far as possible, because 100% accurate will not be ever possible, because that is the real world which is the only one which is the 100% accurate. So because ultimately it would be a model, it is a representation of the terrain, it is an abstract form, abstract representation of the terrain. So there always be issues about accuracy, there always be issue about the resolutions, but the nonetheless whatever is available, which can be definitely exploited nowadays for various applications which we have already discussed. So DM accurately replicate both landscape form and processes are critical to support modeling of environmental processes. So various applications are there, whether somebody is planning an infrastructure network, conducting a military interventions missions, or for a unknown terrain, or analyzing terrain features for oil or gas or water, minerals, everywhere you require a very accurate representation of the terrain. And generally many such applications analysis requires a high accurate. Now these are relative terms, accurate, high or high spatial resolution. These are, we started with 1 kilometer spatial resolution DM of USGS, which was generated using survey topo sheets. Now we are talking about digital elevation models of 5 meter. Still the discussions about accuracy and spatial resolution will keep happening. But one should, whatever is available should exploit to the maximum and create useful and reliable outputs as far as possible. So this accuracy of DM usually represented by spatial resolution and height accuracy, and this accuracy influences results of course, and therefore optimum accuracy. So this is more appropriate term here. Rather than absolute accuracy, we should look for optimum accuracy for DM for different kind of analysis. Now the sources, which are the sources from where I can get digital elevation models. So the sources which I am going to discuss here in or have been discussed in this table mentioned are the open access, open sources through net you can find. And of course, if you want your own digital elevation model with high accuracy and high spatial resolution, then one can buy the stereo pair data like from Cartosat or other satellites and can generate using this photogrammetric techniques to generate digital elevation models. So that possibility will always be there, and we can even go for higher and higher spatial resolution digital elevation model. But what we are discussing, the open access which are available free of cost and which has been generated or put on different portals by different organizations. So one has to be careful about while searching all this whether a particular digital elevation model is global or regional or that kind of thing for some specific country. So global part is important, and then like for example SRTM DM. Now SRTM DM is a global digital elevation model, and whereas this like Aster DM is also a global GDM, that is global digital elevation model from Aster satellites, and this ALOS 3D word, this is also global, but our Cartosat DM is only regional and only for India. So that one has to know before going for that data. Another important thing one should know for which area, whether it's a flat area or hilly terrain, he is going to use digital elevation model. You have we discussed once in a lecture that when we analyze different digital elevation models of 30 meter resolutions of different kind of terrain, we found different digital elevation models having different accuracies. So accuracy will depend how they have been generated, and for some areas this INSAR based digital elevation models like SRTM may be very good for plain areas, but if you go in a hilly terrain like Himalaya, then there will be a question mark in relatively with the INSAR data. Whereas the stereo data are very good for hilly regions, but may not be that good in plain areas or completely flat areas which are without land features or landforms. Their stereo pair data the digital elevation models like Aster DM, which has been based on this stereo pair technique, may not give good results, but they are giving good results for hilly region. So that is why I said for which area you are going to use, accordingly you choose different. They are all available for different resolutions, like all are roughly available for 30 meter resolutions. Even Cartosat digital elevation model only for India you may get a 10 meter. Now vertical height, or that is the vertical height resolution, of course this is all in meters, 1 meter least count, but the accuracy part, it is always a sort of that is the mandatory information by these organizations who have developed different digital elevation models to provide that information too, because in your scientific research or other domains you require that information also. So, like if I take this SRTM, there is a about 7 meter by the person who has analyzed the data, or the organization which developed this SRTM DM, they claim 9 meter. And then Ester GDM is 11 meter in that sense. But again, this will depend where you are located, whether hilly region or plain region. With this analysis or in this table, an average value has been given. And then this JAXA Global ALOS 3D world site, from there you can get a 5 meter. So, this is providing a very good vertical accuracy as well. Now, these are the informations about from where one well known portal, which is Earth Explorer, and this is also available. Aster GDM, SRTM DM, all are available on Earth Explorer. Then on the JAXA site you can get this digital elevation model, and then of course on the Bhuvan, through Bhuvan you can get Indian one. I think now they are not providing at 10 meter, they are providing now at 30 meter, maybe some reasons I do not know. Now, further on this which we have just discussed about this, that there are many other sources may not have the global digital elevation model, but regional one. So, like bare earth DEM, you require this bare earth, recall this discussion bare earth because when we discuss about this laser based techniques, and there we lidar based techniques where we discuss this bare earth, because other digital elevation models are representing top of the surface including features. So, when you minus features, then it call bare earth. So, this bare earth DEM is having vertical accuracy 5.9, 90 meter resolution only. So, and then again 90 meter, this is earth ENV, then 10 DEX, again it is 30, it is available 30 meter, 90 meter, and this is INSAR based. The important, it is global one, and the merit is also global one, but it is at 90 meter, 5 meter. And these are the names of the portals or addresses of portals are given here, which one can definitely access. Now, this is the screenshot of that Earth Explorer site, which you can see here. Very easy to get the data. You just put these details here, and very easy to navigate here, and then you start getting the data, and which you can you get the link, easily download that one. So, you can get from Earth Explorer, SRTM DM 30 meter, 90 meter, 1 kilometer, Ester 3D DM, that is word you can get again of 30 meter. So, plus many satellite data are also available from Earth Explorer. This is one of the best sites I have found for such kind of data. And there are other like tile graver, SRTM tile graver is also there, where you provide details little differently, and individual tiles you can select if you know, and then download. So, this is SRTM tile graver interface for SRT. Same data sets you may find on various sites. So, that does not mean that if one site is different, the different data set. If it is SRTM DM, almost in all sites you will get the same data set. So, this is this was the JAXA one also, and there you also get, and then like this is Bhuvan. Bhuvan, not only you are getting tiles for India, but a subcontinent also, and there it is also relatively easy to navigate, that you choose the like a carto set of all versions I have chosen here, and when you get this grid will be available, you select individual cell of this grid, and you get this data. Or you can provide your latitude, longitude, and then it will provide you what tiles would cover that area, and you get the link. You can download the data free of cost. There are other sources of digital elevation models like Earth Science Data Interface. ESDI used to be very good earlier, popular one, but a lot of changes has happened. Nonetheless, this site is still available, which is a global land cover facility which is run by University of Maryland, provides basically free access to SRTM data. As a bonus, you can download Landsat images already aligned to SRTM tiles. So, for the same tile you also get a satellite image as well. So, you do not have to organize the things would be georeference. For the same tile you get the data. And of course, the digital elevation data for entire globe now also available on CGR and CSI geoportal as well. So, a lot of sites are coming, very friendly sites. Recall the errors in SRTM. So, this whole field or void field seamless SRTM of 90 meter resolution, even nowadays 30 meter from various sites can also be acquired. You may get a degree tile or 5 degree tile. If it is resolution is relatively coarse like 90 meter, then tile size will increase, that is 5 degree by 5 degree. If it is 30 meter, and then the tile size will have 1 degree by 1 degree likewise. So, there are various sources are available, and both these available in both an ArcGIS and GeoTIFF format to facilitate ease of use. Because they are already georeference, and it is I prefer always downloading in GeoTIFF format. So, if I want to use in any other software, I should not have any difficulties whatsoever. ArcGIS or popular softwares will always accept different types of formats for these grid data sets. Now, another source of information can be NGDC, which is the National Geophysical Data Center, which offers the gridded global relief data, images of multiple resolutions, or 2 minute means rather than 1 degree, you get to more detailed one, that is the 2 minute gridded global relief for both ocean and land areas. You also get the bathymetry data, topography, all are available of this eTopo2 database, that is also there. And now 30 arcsecond gridded land topography are also available at 1 kilometer base global project data file. Lot of sources are there. Now, depending what you are looking for, what you are going to use it. So, starting from 1 kilometer and to 10 meters, you are having, that means the 1000 meters to 10 meter, you are having digital elevation models generated from different techniques are available on net for you to download and utilize them. Of course, their accuracy will depend on resolution as well as which part of the world, how the terrain is. So, in January 2015, this release of includes most of this from this site, and the Asia now include India, the East Indies, and Australia, New Zealand, islands of Western Pacific. All for that the data is available. Now, we reach to a section of digital elevation models which is about the limitations of. So, first limitation is in the word itself, that is the model, because model is an abstract representation, that is not the real world represent. Real world is really on the 1-to-1 scale. So, whenever there is a modeling is done to anything, then some errors or limitations will always be there. So, one of the limitations which have been always in discussion is about spatial resolution. As I mentioned that when we had only 1 kilometer spatial resolution digital elevation model at global scale, we were saying that it would have been better if we get a spatial resolution digital elevation model maybe at 50, instead of 1000 meter, if we get 500 meter, that would be wonderful. But then from 1000 meter we came to 90 meter. For some time people were happy. Then again they started looking for higher and higher spatial. So this is this desire for higher and higher spatial resolution will always remain whether it is a digital elevation model or related with the satellite images. Nonetheless, now vertical resolution or the least count of the elevation value, that is equally important. So before you download any data, the best thing is to read about that particular data set, especially the meta files and details, how this has been generated, what is the accuracy part, how this vertical resolution has been handled there. So lot of your reliability of your studies will depend on the input, this information, and whether the coverage is global or regional. If you are working in a small area, then it's fine if you are available regional. Because the best part, if you are downloading a data set which is a global, because if the particular data set available like a GDM or SRTM, then thousands of people or millions of people world over are utilizing that data, and they have analyzed, they have checked from every point of view. So that kind of information which you would have against a global digital elevation model, which you may not have regional. For example, if I say about Cartoset, so whatever this NRSA or ISRO people will say, we have to believe, because that is not globally available. If that data set, Cartoset DEM would have been available for entire globe, then world over people will use that data and then they will comment on the accuracy of the data. Not only the spatial resolution, but accuracy, vertical accuracy as well. So that opportunity will not be there if, or that information will not be available to you if you are using regional one. But that would always be available to you if you are using the global one. Now, age of DEM. Sometimes it can be very, very useful if I am detecting a change detection study while discussing about erosional features and other things. I mentioned that if I am having two digital elevation models of having say 20 years time difference, then I can know that where and how much changes have occurred. Assuming that these both digital elevation models which are have been used for this kind of calculations having relatively good accuracy. But if I am not doing a change detection study, I would like to use this DEM along with the say satellite data or for any other purpose, then it has to be latest. If it is latest, then for various applications it would be really very useful, and the output which I will create will be highly reliable, like in flood studies. Because every year along the rivers, if floods are occurring, they will keep changing the landscape, and there might be some shifting or changes or in the meanders or shape or geomorphology or fluvial geomorphology of the river. So if I am having a latest digital elevation model on which I estimate the flood scenario, then I am going to have a quite good accurate. But if I am having 20 years old digital elevation model, then so this is age is also in some cases is limitation. May not be in many geological studies or but for many civil engineering projects also, age of digital elevation model can play very, very important. So before employing a digital elevation model for such projects, such studies, one should also know when it was created, how it has been created, what is the accuracy. Apart from that, when it was created also becomes important in many studies. Now, under this further in this limitations of digital elevation models, that areas related to DEM uncertainty that affects the use of DEMs. And this also we have used while discussing about the accuracy of a digital elevation model, especially how to assess. Then we said that these are spatially they vary, the accuracy part varies, so uncertainty will also vary. That means within a digital elevation model file, some part may have very accurate representation, some part may not have very accurate representation of elevation against those particular cells. So, this we have to be careful while employing digital elevation model. So, what are the important DM errors? Of course, they play very important role. Topographic parameters frequently derived from digital elevation models, slope aspect starting, and then you end up with the surface hydrologic modeling and sediment yield and other things. So, all these will depend because they are derived from digital elevation. So, this error will influence our results which are based on digital elevation. Influence of DM scale is imposed by grid cell resolution. A very coarse resolution digital elevation model, if it is being used as a large scale, you will have problems. So, both vice versa is also true. So, one has to struck a optimization with the spatial resolution and the scale. Nowadays, most of the things are being done on digital platforms on screens. So, sometimes only at the time of display scale will matter. Otherwise, as long as the data inside the computer, scale will not matter. And of course, the DM interpolations, which technique it has been employed to interpolate using the point heights, that also plays very important role. Though we have already discussed in detail that how to assess which interpolation technique is best suitable for that set of data before I go for interpolation. So, that assessment one can always employ. Now, also that terrain surface modifications keep happening and which we use in hydrological analysis. So, that is why I said that the age, basically these modifications are related with the age of a digital elevation model, because we know that these things keep happening. So, terrain surface feature modification used to generate hydrologically viable DM these surfaces, and error in digital elevation models and propagation of the error to drive terrain parameters. Remember that this point will further come in our last two discussions, especially the sources of errors in GIS. That error, one of the basic understanding about the errors in GIS is that error propagates in GIS, and therefore I have been saying throughout this discussion or in this course that check for errors after each and every step of your operation, and if found, correct it there itself. Don't leave for others to correct it, because error propagates in GIS. Therefore, even if I am using a digital elevation model, I must be aware about what kind of error or accuracy, and then this propagation should be avoided as much as possible, because errors should be contained. They should not be allowed to propagate in GIS. The purpose of GIS is not to introduce errors. The purpose of GIS to keep errors at the minimum, because if my output becomes highly unreliable, then no use of doing that exercise. So, now different applications may require different spatial resolution DMs. For all studies, what it means basically, for all studies you do not require always high spatial resolution digital elevation. Sometimes I have used 1 kilometer spatial resolution digital elevation model, sometime I would like to use even 5 meter spatial resolution digital. So, various applications will require different spatial resolution digital elevation. So, for like hydrologic applications, 90 meter spatial resolution is sufficient to capture the terrain variability for subsequent hydrologic modeling in the study area. So, people have assessed this thing and they found that this is optimum, fantastic, no problem. Why to go even in freely available 30 meter, but why to go unnecessarily? For hydrological applications, which involves a large area. For landform classifications, in case of 50 meter digital elevation model, we can still categorize things. So, they again is there. For terrain parameters, the optimum grid cell size is between 5 to 20 meter, depending on the terrain complexity and of course, the application. and terrain derivatives, which product I am trying to derive. But these are the basically these are the judgments or opinion of different authors which they have written in their publications. You may find little different experience, but more or less one would reach to around those figures or those spatial resolution. For very highly accurate DMs generally are required for floodplain modeling, because this you really require a very high because it affects the life and the infrastructure. So even a 1 inch extra water or 1 feet extra water can create havoc in an area. Therefore, you require a very accurate digital elevation models. And also whatever the best available, one can exploit and then assess the quality of digital elevation models. So the best available conventional DMs have a spatial resolution of 10 meter, a vertical spatial accuracy of plus minus 0.5 meter, which is too great for the effective as us for hydraulic models, if it is available. So if it is not available, we cannot do anything. Now here, this spatial resolution, sort of a last discussion on spatial resolution, and few years back I found this nicely drawn figure, and though here the quality you may not find very good, but still this is what is very nicely depicted with the time how things have changed and what are the desirable spatial resolutions for satellite data. Same we can link with the digital elevation models as well. Like here, few years back even 100 meter was the desirable, and the resolution in time, how frequently the data should be available, was in like every half an hour people wanted. But what was available were at this stage, that if I go, then they say that this is the like 5 kilometer and above spatial resolution is the worst scenario. The present scenario presents the best one was here, but you cannot have digital elevation models for any part of the globe on very frequently basis, because it requires resources to generate a digital elevation model. So this discussion about spatial resolution will keep happening as new data sets becomes available, new applications comes, and this will keep going on, and this desirable, the area which is shown here in this figure will move here, and this may become very narrow in that sense that I require only this now, but this will keep happening all the time. So these things, yesterday whatever was the high spatial resolution is no more now high spatial, that is now considered a coarse spatial. For example, 90 meter spatial resolution digital elevation. Few years back, relatively as compared to 1000 meter, 90 meter was really high spatial resolution. But people now they call as 30 or 12 meter or 5 meter is high spatial resolution, not even 30 as a high spatial resolution. So this keep changing, it's a relative term. Now the desirability of higher spatial resolution basically is getting influenced because of the requirements. More and more detailed investigations are required, are happening, and will keep happening. Of course, it depends on the availability. So availability with increasing with time, more available, more options are available. Not only on USGS topo digital elevation models, but I have shown you from several sources you can get digital elevation model. And for many countries, many other options are also there, because those are not global digital elevation. Now our processing capabilities is also increasing, and therefore our machines, computers, softwares are capable of handling high spatial resolution digital elevation model. That means they are capable of handling large files. Earlier they were not there, things used to become very slow. So therefore, these things goes hand in hand. more the high spatial resolution data becomes available, same time your computer technology is also improving, software technology is also improving, and all these are bringing better and better opportunities to work. Now, envisaging from local to global analysis models, people are expanding their areas. They do not want to now concentrate only on the local studies, they want to do it at continental scale, even at a higher spatial resolution. So, you require fast machine, you require that kind of accurate data, high spatial resolution data as well. Now, little bit about the future of digital elevation models. People are thinking now for, of course, high spatial resolution digital elevation model, but NASA is thinking in the creating a new digital elevation models and associated products. And of course, it is going to be on a what I would say very high spatial resolution, and that too on a global scale, and maybe of 2 meters or 5 meters. So, it is a proposed that a significant modernization of publicly and freely available digital elevation model may take few years, nonetheless things will come. Like current SRTM DM product is most intensely downloaded data sets, because it is available at different 1 kilometer, 90 meter, 30 meter. So, people are very familiar and comfortable with that data set. However, due to number of restrictions and limitations, the original full resolution DEM and error backscattered coherence layers were not released to the public, because these are related with your SAR interferometry. So, that information is were not available or were released. Now it is proposed to process or reprocess the original SRTM data, which was collected through a mission with improved algorithms and incorporating ancillary data that were unavailable during that time of SRTM processing. So, even if that reanalysis is done with improved algorithm with the SRTM data collected, then we can have again a high resolution or better quality digital elevation. Quality means here accuracy I am talking. Now, what is this market? And of course, the dynamics, it is ever changing. So, DMs are used across various and use industries such as telecom, aerospace, defense, telecom, mining, oil, etc. Of course, in research and education. And upsurge in different end use product, that is the demand and industrial development, are the two crucial factors which basically compelling the demand of better and better digital elevation models. When I say better, I means highly accurate and maybe high spatial resolution DMs. So, DM market is still very big, and people are looking somewhere about this accuracy currently in spatial resolution, not really accuracy, but spatial resolution. Of course, accuracy they too are looking for high and high. So, the end users are ready to pay heavily for products with the very high spatial resolution digital elevation models, because they need these products to fulfill their demands. What are their demands? For topographic surveys of a site or local requirements. For many detailed surveys, they require a digital elevation model at a very high spatial resolution. So, that area is always will remain open for development, because this is locally these might be required. High spatial resolution digital elevation models may not be very useful for continental or global scale studies, but for local scale studies where for certain project things are required. So, people would like to replace these topographic surveys and would like to have a high spatial resolution digital elevation model. And of course, the precisely why market players are trying to develop high spatial resolution, private agencies as well, high accurately DMs, as they are expected to register high demand in near future. And the quality and availability of remote sensing data, that has tremendously improved in last few decades. So, that too is because many digital elevation models which we have been discussing, their basis is remote sensing data. So, as that technology is improving, this technology or this output, this product is also improving. Now, this with the high resolution Earth observing satellites, as I have said, which is a ever growing number, many countries are having their own satellites, and they too are producing data at high spatial resolution. For example, here the products are available where you can see individual aircraft very clearly, individual trees, houses. That this is of course an orthorectified Pleiades satellite image on the left side, which you can see is how much details are there. And then a DSM, digital surface model, has been generated for the airport which of a city which is Mashhad in Iran. Luckily, I have visited that place. And the availability of high quality input data allows basically providers to quickly create increasingly precise digital elevation models. So, the speed is also very much in certain projects may be of high demand, and this is the demand for homogeneous large area. So, once it is developed for local, people start thinking regional, and then finally they start demanding for global scale digital elevation models at a very high resolutions and of course with high accuracy. So, quality data people are looking. With this satellite Pleiades, one can expect even 0.5 meter, 50 centimeter digital elevation models are possible with these data sets. As you can see what kind of detail it is there. These are some sample pictures. This is from Spot 6 high resolution data sets, and this Pleiades can collect stereo segments of 280 kilometer long and of course 120 kilometer in tri-stereo segments, and therefore creating a digital elevation model with such things becomes possible. Only you require a very sophisticated algorithms as well as software, expensive software to generate, but things are being done anyway. And then one can really quickly, one can generate a 3D coverage of a metro city, and all necessary input can be collected in a single day. Like here, though it is the example of Spot 6, but in future we will be also seeing a digital elevation model at 0.5 meter resolution coming from Pleiades. So, with this I end this discussion. Thank you very much.